Hi, welcome to this Corporate Maths video. In this video, we're going to look at how to find y if we've been given dy by dx. Or it may be worded slightly differently. You may be asked to find the equation of a curve if you've been given the gradient function. So you might want to find the gradient of a curve if you've been given the gradient function, or you might be asked to find y whenever you've been given dy by dx. Now, we've looked previously at how to find dy by dx if we've been given y. So to find dy by dx, the gradient function, you differentiate if you know what y is. So if we want to go backwards and we want to find out what y is, we're going to integrate. And we've looked at previously what integration is. It's the reverse process to differentiation. So we want to integrate. So we want to increase the power by 1 and divide by the new power. And that'll help us find out what y is. Okay, so let's have a look at our first example. So our first example says, express y in terms of x if dy by dx, the gradient function, is equal to 2x. And we've been given that y is equal to 19 whenever x is equal to 4. And that's quite important. Whenever you're asked to find what y is, whenever you're given dy by dx, you'll be often given some information like this, that whenever x is equal to this, y is equal to this, or you might be told a point that the curve passes through. And that's important to help you find out what the c is whenever you integrate. And we'll talk about that in a second. Okay, so we know that dy by dx is equal to 2x. So the gradient function is equal to 2x. If we want to find out what y is, we're going to integrate. So let's integrate 2x. So we're going to integrate 2x with respect to x. So to integrate, we're going to increase the power of x by 1, and then we're going to divide by the new power. So the power at the minute is 1. It's 2x to the power of 1. We tend not to write a power of 1. So we're going to increase the power by 1. So at the minute the power is 1, we're going to increase that by 1, so it'll be 2. So we're going to write x squared. So we've increased the power by 1. And then we're going to divide by the new power. So we're going to divide this 2 by the new power. And 2 divided by 2 is equal to 1. So that's equal to 1x squared, but I'm just going to write x squared. And remember, whenever we integrate something like this, 2x with respect to x, we'll have that plus c on the end. Okay, so we've integrated and we've found that y is equal to x squared plus c. So this is fantastic. We know that y is equal to x squared plus c. But we want to find out what the c is, because if we consider this and we think back to differentiation, and whenever we looked at and introducing differentiation, I started off with y is equal to x squared, so this graph here, and we differentiate it. So if this is y is equal to x squared, and we differentiate that, we get that dy by dx, the gradient function, was equal to 2x. And it's saying the gradient of this curve at any particular point is 2 times the x coordinate. So at this point here, the point 0, 0, if you want to find the gradient at this particular point, so the gradient of the tangent at that particular point would be equal to 0, because 2 times 0 is equal to 0. If we want to find the gradient at this particular point here, the point 3, 9, we would look at the x value, which is 3, and we substitute it in here, and we would do 2 times 3 is equal to 6. So the gradient of the tangent to the curve at that particular point, 3, 9, would be equal to 6, and so on. Now, if we had a different graph, perhaps the graph of y equals x squared plus 1, and remember that adding 1 to a graph just moves it up 1 square. So if this is the graph of y equals x squared, so if this is the graph of y equals x squared, the graph of y equals x squared plus 1 would look like this, where it's been shifted up 1 square. So that would be the graph of y equals x squared. It's the x squared graph, but it's 1 square higher. Now, if we differentiate it, so if we differentiate y is equal to x squared plus 1, we get that dy by dx is equal to, well, bring down the power, so 2x, and then reduce the power by 1, so 1, so it'd just be 2x. And when we differentiate this 1, that becomes 0. So this plus 1, when you differentiate it, you just get 0, because it doesn't affect the steepness of the graph. If we consider this point here, the point 0, 1, so this point down here, the gradient of the tangent at that particular point of this curve is still 0. 2 times 0 is 0. The fact that it's 1 square higher doesn't affect the steepness of that particular point. The point here, which would be the point 3, 10, because 3 squared plus 1 is equal to 10, the gradient at that particular point, well, that tangent at that particular point would be 2 times 3, which is still 6. So the gradient function of this graph is the same as the gradient function of this graph, because it's just 1 higher. So that's why whenever we look at this one here, they've given us this bit of information here, because we need this bit of information to find out if we consider that original curve, was there a plus c, and if there was a plus c, what's the value of it? So that's why whenever you're in these questions and you want to find y, or the equation of the curve, and you've been given what dy by dx is, or what might be called the gradient function, you will need to know the coordinates of a particular point that the curve passes through, or be told some information like this, that whenever y is equal to 19, x is equal to 4. Okay, so let's use this bit of information to find out what the c is. So let's do that. So if we substitute this in, so let's substitute these values in. So y is 19, so we get 19 is equal to x squared. Well, it's going to be 4 squared, so 4 squared plus c. And 4 squared is equal to 16, so we get that 19 is equal to 16 plus c. And then if we take away 16 from both sides, we're going to get that c is equal to 3. So that's fantastic. We found out that c is equal to 3. So we've been asked to express y in terms of x if the gradient function is equal to 2x. And given that the fact that y is equal to 19 whenever x is equal to 4, that means the answer would be y is equal to x squared plus 3. And that's it. And you can check your answer. If you differentiate this, you get that's equal to 2x. And if you substitute these values into the equation of the curve, you get that 4 squared is 16 plus 3 is equal to 19. So you get that y is equal to 19. So we've expressed y in terms of x. And that's it. So just to explain that if you want to find out what y is, whenever you've been given what dy by dx is, you'll want to integrate what dy by dx is, and you'll find out what y is. And then you'll want to substitute in the values to find out what the c is. And that's it. So let's have a look at another example. Okay, so this time we've been asked to express y in terms of x if dy by dx is equal to 6x squared minus 2x minus 7. And we've been given that y is equal to 3 whenever x is equal to 2. Okay, so to find out what y is, we want to integrate. So let's integrate this. So the integral of 6x squared minus 2x minus 7 with respect to x. So we want to integrate this. So to integrate this, let's integrate each term separately. So let's start off with the first term. To integrate the first term, so when we integrate, we're going to get what y is. So when we integrate the first term, we're going to increase the power by 1, so it becomes x cubed. And then 6 divided by the new power, 6 divided by 3 is equal to 2. So we get that y is equal to 2x cubed. So we've integrated the first term. Now let's integrate the next term. We've got minus 2x. Well, if we increase the power of x by 1, it was 1. You're increasing it by 1, so it'll be x squared, so x squared. So we're now going to divide the coefficient by the new power. The coefficient was minus 2. Minus 2 divided by 2 would be minus 1. So I'm going to write minus. I'm not going to write minus 1x squared. I'm just going to write minus x squared. Okay, now let's integrate minus 7. So that'll be minus 7x. Whenever you're just integrating numbers, you just put that x on the end. And then also remember the plus c. So that's fantastic. We now know that y is equal to 2x cubed minus x squared minus 7x plus c. But we want to find out the value of c, so let's substitute these values in. We know that whenever y is equal to 3, x is equal to 2. So let's substitute those values in. So y, that's 3. So we're going to get 3 is equal to 2x cubed. So it's going to be 2 times, and then x is equal to 2, so 2 cubed. And then minus 2 squared, so 2 squared, minus 7 times 2 plus c. And then let's work this out. So we've got 3 is equal to 2 times 2 cubed. Well, 2 cubed is 8 times 2 is 16, minus 4, and then minus 14, and then we've got our plus c. So if we simplify this, 16 take away 4 is 12, take away 14 will be minus 2. So we've got the 3 is equal to minus 2 plus c. And then to work out c, we just add 2 to both sides, and we get the c is equal to 5. So c is equal to 5. And that means if we put the c into this, we're going to get that y is equal to 2x cubed minus x squared minus 7x, and then plus 5. And that's it. That's the value of y. And to find that, we integrated what dy by dx was, and then we substituted in the values of x and y to find out what c is. And that's it. Okay, let's have a look at our next question. So our next question is worded a bit differently, but it's the same technique. So instead of being given what dy by dx is and being told to find out what y is, we're told the gradient function of a curve, dy by dx, is equal to 2x plus 3. The curve passes through the point 1, 8. So the x coordinate is 1 and the y coordinate is 8. So whenever x is equal to 1, y is equal to 8. And we've been asked to find the equation of the curve. And remember, the equation of the curve will be in the form y equals something, and we want to find out what the something is. So the steps are the same. We're going to integrate what dy by dx is. So we're going to integrate 2x plus 3, so 2x plus 3 with respect to x. So we're going to integrate that, and we're going to see what we get. So when we integrate dy by dx, we'll find out what y is. So y is equal to, and we're going to increase the power of x by 1. So it was 1. We're going to increase it by 1. So it's now x squared. So x squared. And we're going to divide the coefficient by that number, that new power. And 2 divided by 2 is 1. We're not going to write 1x squared. We're just going to write x squared. So we've integrated 2x. And that's equal to x squared. Now let's integrate the 3. So that'll be plus 3x. When you integrate a number like 3, you just get 3x. Or if it was 9, it'd be plus 9x and so on. And then we've got our plus c, our constant of integration on the end. Okay, so that's fantastic. We now know the equation of the curve will be y equals x squared plus 3x plus c. And we want to substitute in our values of x and y to find out what the c is. So let's do that. So y, that's 8. So 8 is equal to x squared, that's going to be 1 squared, plus 3 times x, that's 3 times 1, so 3 times 1. And then we've got our plus c. Okay, so 8 is equal to 1 squared is 1 plus 3 times 1 is 3 plus c. So we get that 8 is equal to 4 because 1 plus 3 is equal to 4 plus c. So that means that c, if we take away 4 from both sides, you get c is equal to 4. So that's fantastic. We know the equation of the curve will be, if we put this into here, we've got the equation of the curve. Y equals x squared plus 3x plus 4. And that's it. So if you know the gradient function and you want to find the equation of the curve, you just integrate the gradient function and you just substitute in the x coordinate and the y coordinate of a point that the curve passes through into that y equals, and you'll find the value for c. And that's it. And so that means that the equation of the curve is y equals x squared plus 3x plus 4. Okay, let's look at our last question. So our last question, we're told the gradient function of a curve is dy by dx is equal to 3x squared plus 2 over x cubed plus 1. And we're told that the curve passes through the point -1, -7. So the x coordinate is -1 and the y coordinate is -7. And we've been asked to find the equation of the curve. So if we've been given the gradient function and we want to find the equation of the curve, we'll want to integrate that gradient function. Now, before we integrate this, we're going to have to rearrange it because we've got the x on the denominator here. So I'm just going to rearrange it first. I'm going to write dy by dx, so the gradient function, is equal to 3x squared is fine because we can integrate that. And then this part here, we've got plus 2 over x cubed. Now I've got another video in corporate maths called integration after rearranging, and that goes through how to integrate whenever you've got x terms on the denominator. But if you've got an x term on the denominator like this, you can just bring it up and give it a negative power. So it's going to be plus, and then we've got 2, and then it'll be x to the power of -3. So we just changed that power from being positive to negative. And then we've got plus 1. So we've just rearranged what the gradient function is. So we've got dy by dx is equal to 3x squared plus 2x to the power of -3 plus 1. And now we can integrate this. So let's integrate that. So if we integrate 3x squared plus 2x to the power of -3 plus 1 with respect to x. And we can put our brackets in there. Okay, and to integrate this, we just integrate each of the terms separately. So let's do that. And when we integrate this, it'll then be called y. So y is equal to, so let's increase the power of x by 1, so that'll be x cubed. And then we're going to divide this coefficient by the new power. 3 divided by 3 is equal to 1. So I'm just going to write y is equal to x cubed. We don't need to write the 1 there. So we've done the first term. Now let's do the next term. So then we've got x to the power of -3, well, let's increase the power by 1, so it'll be x to the power of -2, just increasing the power by 1, because if you're at -3 and you got 1, you're going to get to -2. And then let's divide this coefficient by the new power. And 2 divided by -2 is equal to -1. So I'm not going to write -1x, I'm just going to write minus. And then we've got 1. If you integrate 1, you're going to get 1x, or just x. And then finally, we've then got our plus c on the end. So that's fantastic. We've integrated this and we'll find out that y is equal to x cubed minus x to the power of -2 plus x plus c. Okay, now this, what I'm going to do with this is, I'm actually just going to put this back on the denominator, because if you've got x to the power of -2, it's the same as 1 over x squared. And think back to your negative indices, if you've got a negative power, you can just put 1 over the positive power. So we've got that y is equal to x cubed minus 1 over x squared, just putting that back on the denominator, putting a 1 there on the top, and then plus x, and then plus c. Okay, this is fantastic. We're nearly there. Now we want to find out what c is, so let's substitute in the values of x and y. And we were told that it would pass through the point -1, -7, so we know that x is equal to -1 and y is equal to -7. So let's substitute those in. So y, that's -7, so -7 is equal to x cubed, so that's going to be -1 cubed, so -1 cubed, and I'll work that out in a second, minus 1 over, and then we've got x squared, so it's going to be -1 squared, and then plus, and then x, which is -1, and then plus c. Now, if you've got a calculator, you can work this bit out, but I'm just going to work it out manually. So you've got -7 equals -1 cubed. Well, -1 times -1 times -1 is -1. And then we've got -1 over -1 squared. Well, -1 squared is -1 times -1 is 1. And 1 divided by 1 is 1. So we've got just -1 there. And then we're going to add -1. Well, adding -1 is the same as taking away 1. And then we've got our plus c. Okay, let's work this out. So we've got -7. -1 take away 1 is -2. Take away 1 is -3. So you get -3 and then plus c. And then here, if we just add 3 to both sides, we're going to get what c is. So if you add 3 to both sides. And -7 plus 3, going back up 3, would be -4. So c is equal to -4. And then if we substitute that back into the equation of the curve, either here or here, whichever one you prefer, I'm going to put it into this one. And I would get that y is equal to x cubed minus 1 over x squared plus x, and then we've got our -4. Or you could write y equals x cubed minus x to the power of -2 plus x minus 4. But either one of those is fine. And that's it. So that's it. So in this video, we've looked at how to find y when being given dy by dx, or sometimes it might be called finding the equation of a curve if given the gradient function. And that's it. And to do that, we integrate and then substitute in the x coordinate and the y coordinate, or the value for x and the value for y, to find out what c would be. And that's it. And I really hope you found this video useful. Thank you. Cheers. Bye.